This is Tier 2 Lesson 6, Factoring by Division. So we're going to use the rational roots theorem to completely factor this cubic. We could use grouping, and we could factor out x squared out of this, and then we could factor 4 out of both of these. But I want to show you the long division. So I'm going to use the rational roots theorem to help us out. I need factors of 8 and factors of 5. So factors of 8 are 1 and 8, 2 and 4, and there are all of them, and factors of 5 are just 1 and 5. Well, this is going to give me a lot. There's all of these divided by 1, and all of these divided by 5. So plus or minus 1, plus and minus 8, plus and minus 2, plus and minus 4, and then all of those over 5, plus and minus 1/5, plus and minus 8/5, plus and minus 2/5, and plus and minus 4/5, right? I took all of those divided by 5. So this is 16 different possibilities. Now, I don't want to sit here and plug in 16 different possibilities to figure it out. So what I'm going to do is I'm going to use my calculator to graph this function to find the root. So here's a root right here. It's between 0 and 1, and that's going to be one of our factors. And I can actually zero in on it using my menu and find the zeros. .4. Well, we know that 2/5 is 0.4, so that's going to be the root that I'm going to divide out. So how do I write this as a factor? Well, I could say x minus 2/5. I'm going to use synthetic division this time because I used long division last time, so I'm going to set that up. Remember with synthetic division, we just used the coefficients, so we'll use 5, -2, 20, and -8, and I don't have any holes to put zeros, so we're good. And my root is 2/5, so I'm going to multiply everything by 2/5. So we bring the 5 down. We multiply 2/5 times 5. Well, we get 2. -2 plus 2 is 0, and 2/5 times 0 is 0. 20 plus 0 is 20, and now we do 2/5 times 20. Well, 2 times 20 is 40. 40 divided by 5, right? Because that was like saying 5 times 1 is 8. And -8 plus 8 is 0. So it worked. And then when I go to put this stuff back in, I have an x here, 0x plus 20, and 5x squared plus 0x. So then there's my factored polynomial, and then my first root was x minus 2/5. To factor it completely, I want to factor my quadratic. So what I can do is I can use the quadratic formula from here because I know that will always work. So here's the quadratic formula again. -b plus or minus the square root of b squared minus 4ac all over 2a. So my a is 5, my b is 0, and my c is 20. So I could do the quadratic formula, but this one's actually going to be a little easier than that. I can take my quadratic 5x squared, this is just 0, plus 20, and I can set it equal to 0. And now I can just solve the easy way. Minus 20 from both sides. 5x squared equals -20. Divide both sides by 5. X squared equals -4. Then I square root both sides. But remember, when I square root x squared, I need plus and minus the square root. So I get x equals plus or minus square root of -4. And then I need to simplify that. So 4 and -1. Square root of -1 is I, remember that. And the square root of 4 is 2. So our two answers are plus and minus 2i. Our third solution was that 2/5 from earlier. Now it says to factor it completely. These are the three roots. If we wanted to write them as factors, we could say x minus 2i, x plus 2i, and then we'd say x minus 2/5, but we're going to slide the 5 over and say 5x minus 2. This would be completely factored. Those are the three roots.